Okay, so what I did in this document was I put together a bunch of little tidbits to help out with what you need to review on specifically for this OpenNote FRQ AP exam we have this year. So I put together a really complete list of information with key links that you can get to if you follow this link here. I'm not going to go into that right now just because you can read through all that later, and I know that many of you already have, but the important parts that I really want to make sure that we see is that there are only going to be 2 questions. Your exam will be 45 minutes long, and it's going to be broken up into 2 questions. There'll be 25 minutes for the first problem with 5 minutes to upload, and then 15 minutes for the second problem and 5 minutes to upload that answer. You are not allowed to go back to the first problem after you do the second problem. And this is unusual because usually in an AP test you have 90 minutes to use however you like and divide it up among all of the problems. However, that is not the case here. It was also mentioned that if you do not submit the problem in the allotted 5 minutes, you will get no credit. So it's really important that you try to start submitting right away and don't wait until the last minute of those 5 minutes. And then they also stressed that whichever device you access the exam on is the same device you have to submit the solution on. They also mentioned that you can choose to handwrite your solution and then take pictures and upload the photos, or you can type your answer on the computer and submit it that way. So there's a variety of methods you can choose. So I would just recommend right now, the reason why I'm having you guys handwrite them now is because I think, in my opinion, that handwriting is harder. It forces you to really know how to write the code, and if you get used to handwriting your solutions, then when it's test day, you're not having to think about how to write a loop and what the syntax is. You're actually being able to focus more on the logic behind what you're trying to write, not how to write a loop. So what I put together in this document are just a number of skills that over the years I've seen on various problems that if you know how to do all of these skills, you should feel very well prepared for whatever they throw at you. So just a couple things in terms of general number skills. We should be able to tell if a number is even or odd, and you can do that by using the percent operator and doing %2, and if the remainder is 0, we know it's even. If it's not 0, then we know it's odd. You should be comfortable with using your percent and division to be able to access specific place values of a number. So remember we talked about how if you take any number that you're given and take that number %10, that will give you the ones place. If you were to take that number divided by 10, that will remove the ones place. So that should be something that you are familiar with. Now, in terms of instantiating objects, on the first free response question that we did during this e-learning set, most students said their biggest problem was they forgot to instantiate their array list, and that is a super common mistake that we make. Now, if you are making a variable for local use, you will often declare it and instantiate it all at once. So this here is where I've instantiated an object. So we have the data type, the variable name, we have to use the word new, and then we call the constructor, which is the same name as the data type, and then any parameters that we need inside the constructor. And then this next one, I'm making an array list. Now remember, an array list can hold any type of objects, and in this case, I'm making an array list of strings. So I'm saying I want to make an array list of type strings. Hold on a minute. Sorry, I had to pause the video and yell at my kids. It sounds like they're putting on a 3-piece band upstairs. My goodness. Anyways, so here, this is an array list, and we have to say what data type is going to go in there. Names is the name of the array list. Now, a lot of times students forget this open and close parentheses after the type of array list. You have to have this open and close parentheses here. And a way that you can remember that is that you are making an object, you are calling a constructor, and a constructor is really a type of method, and methods need those parentheses. Now, other times that we would instantiate objects is when this is going to be an instance variable in a class. And when that happens, we are going to make a private variable. Remember, those variables have to be private, and it would be declared after our class header. So in this case, I'm going to make a class called student roster, and in here I'm going to have an array list of student objects. And then when I create in a driver program or elsewhere a student roster object, I would call my student roster constructor. And since my student roster contains an ArrayList variable, I have to instantiate that ArrayList variable so that it is ready to use. And so that's what I am doing here. So we just want to be real comfortable with this notation that we declare the variable up top where we declare all private variables, and then if any of those variables are objects, those objects get instantiated in the constructor. Now when we're working with basic arrays, there are a couple ways that we can do that. The simplest way is to use an initializer list, and we can use this when we know all of the values of the array at the beginning. This is used a lot if we know, for example, like if we're doing the ages of our kids or the days of a week, months of a year, etc. We don't need to enter them all one at a time. Now, if you want to use this format, this has to be done on the same line as the variable declaration. So right here is where I am declaring an array of integers. I would have to use the initializer list on the same line. Now notice that nowhere here am I saying the size of my array. That's because the computer will tell the size of the array based on how many elements there are separated by commas. Now, let's say I don't know what my values are going to be in the array. I can also declare the array and then fill it later. And that's what I'm doing in this example here. So I'm making an array of size 10. So this is going to have 10 slots that are ready to be filled. And then I can go ahead and I can fill those slots at a later time using index notation. I can also fill those slots using a loop. So here I'm using a for loop, and I'm going from the first entry all the way up to the last. So since our indices for any array go from 0 to length -1, by having my for loop go until I is less than array name.length, then that will go to the last index of my array. All right, now another common mistake that students said that they made was that they used .length with parentheses when they were writing their code, or they confused it with .size. And those are, common mistakes to confuse .length parentheses, and .size parentheses. One of the nice things to know is that that is what they call a freebie penalty, and they do not penalize you for making that error. However, if you were to type your code in Eclipse for your AP test, the compiler would actually catch that error as being a typo and would tell you that that doesn't make sense. So that might be an advantage that you could have this year that others wouldn't have. Another thing is I would never recommend using the less than or equal to here. Whenever people use less than or equal to, they typically end up going out of bounds. So that's why our most common way of writing our loop is for starting at 0, going until we are less than the array name.length, and then increasing by 1. All right. So we talked a lot about using for each loops, and we talked about how they can be very helpful because they are simpler to write. And the other nice thing about a for each loop is that they prevent us from going out of bounds because the indices are already taken care of by the for each loop. Essentially, this is an abbreviated notation that we can use when traversing or going through an entire array or list, and it's going to visit every element starting at 0 until the last element. So you'll see throughout my document, I'll use the word list and array list interchangeably. An array list is a list, and so they work interchangeably. For our purposes, they work the exact same. So when would we use a for each loop? Well, we would use a for each loop when we want to access every element and check its value. If we're looking to see if something is there, if we want to print every value, those are times when we would use a for each loop. But there are definitely some limitations. So here I put together a list of a couple times when you would have to use a regular for loop. So if we wanted to instantiate new objects in an array or an array list, you cannot instantiate objects with a for each loop. You must use a regular for loop. If we only want to visit some values, so let's say we don't want to go from 0 to the end. Let's say we wanted to start and stop at different values, or we wanted to count by 2 or 3. In that case, then we would use a regular for loop. And if you wanted to actually change the value that's in the array, when we use this for each loop notation, we're actually making a temporary variable. And so if you try to, for example, let's say you had an array of integers, that's what I wrote here, and you wanted to add 2 to each value, if you used a for each loop, all that you're doing is adding 2 to the temporary variable. You're not actually changing the value in the array. However, if you were to have an array or an array list of objects and you wanted to call a method on every object in that array or array list, then that could work, because even though it's a temporary variable, that temporary variable is a pointer to the address of the actual variable. So it's kind of like how we talked in class about how if I give somebody a copy to the key to my front door and they were to come inside my house and do something, that would be like calling a method. The changes or the things that they did would still be there when I came home using my key. So on these next few pages, I just put in a couple code examples so that you would have some examples of well-written code. This is an example of an array that's been created using a regular for loop and then adding 1 to each value. Now in this case, I wanted to check to see how many values in my array happened to be divisible by 2. Since I wasn't changing the values, a for each loop would work just fine here. So I initialized my counter, and then I went through and int a in nums. The way that this works is every single value. So the first time through, a is going to equal 3, and I will check if 3 divisible by 2, and it's not. So now I go through it again, and now a is equal to 4, and I check, is 4 divisible by 2? And it is, so I increase count. And now I go through it again, and a is equal to 5. So every time I go through my array, a takes on the value of the current index I am at. So notice here, there is no index notation. It's way simpler to look at. I just say a. Now, I don't know which value I'm actually on. I don't know the index location, which is fine because I don't really care where I'm at. I'm just trying to see how many values at the very end were divisible by 2. Now here, let's say I'm trying to find the location of a specific value. And let's say I had a method, I passed in an array, I passed in a value, and I'm trying to find the index of where that value is found. So if I happen to find the value, I want to return its index. Now what this would do is this would return the location of the first occurrence. So as soon as we find the value, it would return I. Now notice I did not use an if else. I used a simple if because I only want to return the index if I have found it. If I said if else, then that would return -1 right away if the first value wasn't what I wanted. I only want to return -1 if the value is not found after the entire for loop has completed. Now, this is a modification of the method above. Here, I only cared if the value was in the array. I didn't care where it was in the array. So here, I simply returned true or false. So because I didn't care about the location, that's why I could use a for each loop and return a Boolean. Here, I cared about the location, so that's why I used a regular for loop. Again, notice the difference in the way that I'm accessing the value. Here, I'm saying ARR bracket I. Here, I can just say A. So it's simpler notation, but doesn't work all the time. And then last but not least, here I have an example using objects. So I made an array list of type bank account, and we've dealt with bank accounts a ton. And I'm adding a new bank account object to my array list. I could have done this in 2 lines. I could have made a temp variable for a bank account and then added that temp variable to my array list, but I just did it all in one here. And then what this for each loop is going to do is it will go through and it will access every bank account and add $100 to them. Even though B is a temporary variable, it is a copy. It is essentially pointing to the same location in memory. So when it goes to this, it's going to point to that same deposit and it will, or the same balance, and it will change that same value. All right, I'm going to pause the video and go through this second part in another video because this software, stops me at 15 minutes, and then plus that'll make it so the video is a little bit shorter. All righty.